Today we're at the Wyoming Dinosaur Center. So let's head inside and see what they have to uncover. Here is one of the first things you see when you walk in is the origin of plants display, where we see some of these very early fern plants that you would get, some horsetails and things like that that appear. They have a lot of beautiful fossilized plants here. If we come over here, they actually have this very beautiful petrified wood display. It shows a lot of the possibilities of how wood can petrify with different minerals seeping in there. We got these conifers and poplar and pine cones. You see that there's a lot of species that still exist today within regards to plants, like ferns and of course woods of sorts. Pine cones are very old. But if we turn around here, we have some of the earliest multicellular organisms, not the earliest, but some of them. Mollusks, we have gastropoda, cephalopods, that can fall into a lot of things within cephalopods. You get squids and things in there. We have bivalves, which are like your clams, your mussels, things like that. So this is a very beautiful display in regards to that. And if we come over here, we have some of the oldest life forms ever, stromolites. About 3.7 billion years old. They're about 4.6, if I'm not mistaken. Fossils of stromolite layered structures built by microbe mats. They'd stack on top of each other, so you get these small organisms that stack up, and they would be compressed through rock and things like that. So you get these layers of stromolite that build up, and it's evidence of early reef kind of situations. Now this, get close to that one if you can, is banded iron formation. That is one of the most important fossils we have. And it's not even a actual biological fossil. It shows that at one point there was oxygen in the environment because the iron is oxidized. So therefore, we know that there was oxygen. We can tell when oxygen kind of entered and became dominant in the environment. If we come over here, we have some of the very early life of creatures that kind of appear. You have those cyanobacteria, those big bulbs of just goo kind of that appear. You get a lot of arthropods, jellyfish appear for the first time. Very organisms that aren't overly complicated. Trilobites appear near this time during the Cambrian, 520 million years or so. Those little sea cockroaches right there, they appear for the first time, and they become very abundant very fast. But if we get down here, this is a beautiful display of all kinds of different trilobites and how unique they are. None of them are the same. We have those ones with the bulbous head. Those would be carnivores. You would have ones with the flat head that kind of goes out. Those are scavengers, kind of. They have those weird spoon things for digging things up. Trilobites basically ended up filling up every possible niche they could, from herbivores to semi-insectivores. There weren't insects, but they were eating like microbes of their time, things like that, to even just being predators of each other. But then we start to get sea scorpions like Euryptids. So you have these beautiful, massive sea scorpions with these huge claws. They got huge. I mean, these things were massive. And this is like a medium, small to medium-sized one. They could get bigger. These things became very top predator, very weird looking. They're not real scorpions. I forget what the technical reason behind that, but they just resemble scorpions with the giant pincers and the weirdly pointed tails. That's why we call them sea scorpions. when we come over here, we get the first arthropods. So you get crabs are a very good giveaway of arthropods, crustaceans, things like that. They get these big pincers, get these flat exoskeletons. These are still invertebrates, so they molt. So this crab would pull out of its shell, and then you would get possibly a fossilized shell there. And then you get things kind of onto land, lobsters of course. You get the first kind of above water creatures like these giant dragonflies. Those appear above land because oxygen was very, very rich within that time. So bugs could get absolutely massive. Then, actually we'll go over the belemnites first. So belemnites, or belemnites, are actually very interesting because they are part of the mollusca group, which is mollusks and things like that. So they're actually nautiloids that shells are straightened. So you'll get a lot of beautiful suture patterns. I don't really see any good examples here of belemnites specifically, but you can see that they have those, they look like a squid. They'd have that giant cone with the tentacles coming out. This is some very beautiful fossils of belemnites and these prehistoric squids. Now we come over to chordates and placoderms. These are the creatures that start to turn into more complicated things. You start to see the rise of vertebrates, the spine, things like that. Chordates aren't exactly, that's those weird freaky things there, that top image. They're not actually vertebrates, but they do have the semblance of vertebrates. It's very weird. They still have that spine. They have like a neural canal, but they're not actually vertebrates because it's not a true spine. It's very weird. But you start to see some very, very bizarre looking creatures like that thing right there. The I think it's called the Gilly monster or something like that. But you start to get a lot of jawless fish. That's the thing. So you have a lot of jawless fish. That's because the jaw actually evolves from one of the sets of gills that comes down to open up into a bottom jaw, that hinge there. But jawless fish, what they'd do is they'd slide across the mud or the slurry at the bottom of the ocean and pick up microorganisms. They'd suck them up and eat that way. But then you start to get these jawed fish, where that, like I said, that that set of gills comes down, slowly becomes like an actual jaw, turns into bone, and we get things like the Dunkleostis. These things were absolutely massive creatures, just powerhouses of their time. They didn't have teeth yet. That is very important. So these are not actually teeth. These are part of the skull that is extended down and sharpened so that they can clamp onto things and bite and pierce. Dunkleostis was reigning supreme during its time until the Devonian mass extinction, whenever cyanobacteria and bacterias laid across the ocean, blocking out sunlight and cutting off oxygen supplies. So this thing died off, but in theory, these things and sharks existed at the same time. So those both could have died off, but we got lucky to just get sharks instead of Dunkleostis. And then if we come over here, we start to see that rise of more modern looking fish. It's very difficult to just say modern looking, but they're fish. You start to see the rise of like actual fish. A lot of ray-finned fish. Those are the ones that their fins kind of look like the triangles. So you start to see that rise of ray-finned fish. And then lobe-finned fish eventually go onto land, and we'll talk about that in a bit. Then we get on to one of the most important things, is the ecological builders, the reef builders. So you start to see sponges and corals and bryozoans and algae and brachiopods. They build up in these little communities in semi-shallow tropical-like waters. And of course, the world at that time was fairly warm, so a lot of reefs could appear in shallow water. So you start to see these things build up on top of each other and build these underwater ecosystems. And, crinoids. Love crinoids, completely underrated. These things are freaky though. I mean, they're not plants, they're not animals, but they live in these giant gardens, and they'll grow out. They're called sea lilies, since they kind of look like lilies, but they're in the sea. So they'll grow in these weird groups, and they have this really weird anatomy to them, and they just look super, super freaky. Here we have this beautiful, just giant trilobite mass death here. It's very amazing. So they must have all gotten to one area, and something could have happened. The rocks from some higher up layer underwater covered them, or possibly just whatever weird part of the water they were in dried out, and they just got abandoned on the sand and died out. Here we have this massive ammonite, very beautiful ammonite here. You see that beautiful coil there? Looks like some kind of possible, not echinoderm, but mollusk or something there. I don't know. But we're going to come over to the actual nautilus and ammonites. So, as I've mentioned before on this channel, ammonites or nautiluses, nautiloids, whatever you want to call them, are still alive. But you can see that they've been around for a long, long time. You get those very early nautiloids. And then we start to see a lot of the ammonites that turn into nautiloids eventually. And you get these beautiful patterns on them. Those are called suture patterns. So if you come down to this one, this is a goniatita. Don't speak Latin. But you can see those very weird wavy lines on them. That's usually a good indicator of how far they are evolutionarily. So the more complicated it is, that usually means the deeper into time they are. But then you see this beautiful Canadian ammonite back there that is made of, it doesn't say, but that is probably from some minerals after it died being dropped onto it. So during the pre-mineralization period, it actually would change it out for those other minerals there. Instead of it just being like quartz or silica, it's something more beautiful. But yeah, that's a beautiful ammonite right there, those big old ones. And they come in all kinds of weird shapes. You see they're not always completely coiled. Those little cephalopods are really weird. And then we're coming back over here to echinoderms. These things are definitely still alive today. You have sea cucumbers, sea urchins, a lot of sea urchins. You have brittle stars, sea urchins plus sea stars, brittle stars, starfish. Those look like crinoids. Yeah, those are crinoids and sea lilies. I don't exactly, well, I guess those are part of the echinoderm family. But you get sand dollars and I forget what the sea biscuits, I think is what they're called. Sand dollars are very weird because they're irregular. I think they're the irregular ones. Maybe it's sea biscuits. I don't remember which one's the irregular one off the top of my head. But yeah, you start to see the rise of starfish where they're not spined. They have it's called like an incomplete food like hole. I don't really remember the technical term, but they have their anus is their mouth. That's a thing that exists for these things. So they're very weird, very just freaky looking. And you start to see that rise up. Then we're going to come over here. We're going to see some big boys with a lot of these fish and marine these like fish, rays, things like that. Those start to appear. There's this giant real fossil of a Hybodontiforms. Had two different kinds of teeth, two in its mouth. One set in the front of the mouth was more robust and were more than likely used to grasp and hold on the prey, while the other set in the rear of the mouth were likely used to crush the prey. You can kind of see that here if you get to that front head there. You can see some of those weird bumps there. I think some of that might be teeth. Which suggests that these things were eating hard-shelled organisms, such as crustaceans and echinoderms, hard-shelled mollusks, and even unshelled prey if it got its jaws on it. But this is a Astracanthus, which is from the late Jurassic, 148 million years, found in Germany. If we come over here, we get the Condorctes, is a group of fish that indicate sharks and rays. So this is where the sharks and the rays start to split off. You get sharks and stingrays. This is that like stingray in between, where you start to see some really weird stuff happen. We got actual stingrays for the first time. Then we start to get spiny, this is spiny sharks. You get to see shark eggs. Get close to see that shark egg real quick. You get to see those really weird carpet sharks, bullhead sharks. Megalodon eventually appears very, very later, but you start to see that divide between stingrays and sharks. So here we get one of the most important evolutionary things that happen, the lobe fin fish. These things get really weird. So this is coelacanth or coelacanth. These things are still around today, which is very interesting. But if you get up close to that fin down there, you'll notice it looks like a lobe, hence the name lobe fin fish. But it starts to look a lot like a human hand a little bit. There's a lot of differences, but you start to see that radius, that ulna, it starts to break off. You can kind of see the resemblance between later on, whenever we start to come onto land, and these things' fins. So you get these very weird looking lobe fin fish. They break off, so you have lobe-finned and ray-finned. Ray-finned stay in the water and keep being fishies. Lobe-finned also a lot stay in the water and keep being fishies, but some actually come onto land. And that is where we start to get the weird evolutionary tree of coming onto land, where we have the ancestral fish down at the bottom, where it still has those lobe fins that kind of come on, but then you get the living in the swamps, where you start to get that shallower water so that they can actually come out of it a little bit. And you start to see that lobe fin very much more predominantly, where you have the radius, the ulna, and then you'd see phalanges coming off. And this thing is a Panodorictus in the late Devonian. Then we get the Tiktaalik, one of the most important stops that we see. The front fins, you'll see, have functional risk, letting the animal push itself up from the bottom, catching prey. So this would be the water to be able to push itself up to catch prey. Then we get the adapted for swimming, where you start to see that the eyes kind of come to the side of the head instead of the top of the head, so it can see out of the water. You start to see that the gills kind of disappear. You see that they start to have those actual fingers. Though this early proto-tetrapod had legs and feet, it was not well adapted for walking on land. It was still think more like a weird amphibian that's more aquatic than it is on the land. So it has the capability of going on the land, but it does need to return to the water. Then we have this little freaker here. This proto-tetrapod lived its lifestyle similar to later salamanders and reduced its size and reduce the size of its limbs. So you'll see that their limbs are very sprawled out because they're heavy, they're heavyweight. They have to support themselves because they're used to being in water. But these little guys start to, you see the lungs start to, not the lungs, but the gills start to disappear. You have like lungfish, you get the eyes on the top of the head, the nostrils kind of come down a little bit. You see that they actually have like hands and things like that. This appears to be a fossil of one of those early amphibians. And of course, we can't talk about the Carboniferous period without bringing up the big flies and insects and things like that. You still have those ray fin fish, things like that. You have extinct synapsids that appear. And of course, amphibians are running basically rampant. But what is a synapsid? These things, this is a Dimetrodon. This is not a dinosaur. Its legs are not under its hips. So I should probably point at the back leg, and diapsid means that they only, or synapsid means that they only have the one hole in their skull, the one extra hole. So you'll notice that dinosaurs a lot of the time have this part of the skull missing, or it's a gap. That's why they are diapsids. These are synapsids. Humans are synapsids. Mammals are synapsids. Kernels are not synapsids, they are diapsids because they come from the diapsid lineage, but they lose that hole, it grows back for whatever reason. I don't really know the evolutionary reason why they do that, but they are still diapsids. This is a beautiful depiction of this early synapsid, which is Dimetrodon, and we're now in the time of weird proto-mammals that eventually are running rampant. So these are actually our earliest ancestors. So you get Lystrosaurus, you get these weird big, like, kind of fuzzy, tusked-beaked cow, pig things. They're very freaky. So you get this, like, weird, just hodgepodge of bone of these, like, proto-mammals. You can see that they have these very bulky skulls. You get these big, they tend to have these big tusks. You have, these are still synapsids here, but you get to see Lystrosaurus down here. This is, of course, one of our oldest ancestors, like I mentioned. But they have this like weird beak and these tusks, and they have these just really weird evolutionary traits. And you start to see into the Triassic, where you get the crocodilians. You get a lot of crocodilomorphs. They start to look like crocodiles. Those fill in a lot of the niches. You have those weird herbivorous ones like the ones up top. They get these giant spikes jutting out. They're basically ankylosaurs or polacanthus or nodosaurs, but they're crocodiles, and their legs are not under their hips. And you get these like just Ornithosuchus, things like that. Postosuchus is a famous one. You get these really weird crocodilians. You get to see the rise of ichthyosaurs during the late Triassic, which is very weird. You get these small ichthyosaurs that kind of appear. Ichthyosaurs are interesting because they kind of follow the dolphin lineage. They're the convergent evolution version of reptilian dolphins. You get these big old eyes that help them see for miles. Well, actually, it helps them see in the dark because it's thought that sometimes they go into deep ocean. They do still need to resurface. They have that weird beak thing. They get these large, flat, paddle-like tails. They get the big old dorsal fin too. So you start to see this rise of ichthyosaurs as well. This is a beautiful theropod track. Make sure I don't run into that. Then you also see aquatic reptiles. You start to see the first reptiles. They become diapsids. They get that extra hole. They just look like reptiles. Imagine just like a weird long neck lizard that kind of lives most of its life in the water. You start to see that. But then we get the first dinosaurs. The best example we have that is usually depicted is Coelophysis. Herrerasaurus was also in this time, and I'm upset that we don't show that often. The Tate Museum had a Herrerasaurus skull, which was beautiful. But Coelophysis was one of the first dinosaurs kind of appearing around the late Triassic from New Mexico. Coelophysis is considered one of the earliest dinosaurs in reach lengths of about 3 meters or 10 feet. The long, slender body, powerful legs, and multitudes of serrated teeth suggest Coelophysis was a fast, agile predator who hunted equally fast prey, such as small lizards and fish. If you look around the ribs of this specimen, you see several small reptile bones. So you'll see some of these bones kind of in the center here. This is probably its last meal, but you start to see that the legs come under the hip. So Coelophysis becomes one of those first true dinosaurs. You start to see those very early theropod teeth. It's got this weird, long, slender neck, and its tibia would have been longer than its femur there. I think that's what it is. Yeah. So it would have been built for speed and pursuit and chasing down quick prey instead of stalking. But whenever the Triassic extinction happens, you see that these are some of the creatures that survive. So then we get to the rise of the dinosaurs. You start to see that dinosaurs become running rampant. Like this beautiful Allosaurus here. This is a beautiful Allosaurus fragilis. You can tell by the thick skull or thick jaws. The crest is a good giveaway, if I had to guess. This is a beautiful real specimens of Allosaurus found from Wyoming. So we're skipping pretty much the late Jurassic here from the Triassic. So you start to see these big predators start to appear. Dinosaurs start to roam rampant. We'll come back here with ichthyosaurs. You start to see more ichthyosaurs become larger during the Jurassic. This is a mother ichthyosaur. So I want to probably say that there is probably, you can kind of see inside its ribs is another ichthyosaur. It's died giving birth, apparently. You start to see these larger ichthyosaurs start to appear. They just get bigger and bigger because the water isn't really as restrictive. You start to see, well, you don't start to see, but you do see the remaining of crocodiles and crocodilians. You have these beautiful scutes, is what they're called, which are like osteoderms. So you see that these things are still around. This is like a slender snout, suggesting its diet was fish, similar to like the modern gharial. So this thing would have been similar to a modern gharial. Here we get, I don't actually even know what this is. Saurocrinus is a commonly found in German's Jurassic Age Holtz-made shale. Unlike other crinoids, it drifted with the ocean currents by anchoring to floating debris. So this would have hooked onto something, this massive thing. See, show how tall that thing is. Would have hooked onto something in the middle of the ocean and floated around with it, gathering its nutrients that way. This is also a crinoid, so crinoids were still around. They're still around today, just not as abundantly. We do see those ray fin fish are still around with this Pachycormus. Now this thing is a beautiful example of trace fossils. This entire section is a horseshoe crab. Horseshoe crabs are some of the oldest species that we have today. And this is a huge trackway of horseshoe crabs. So you're able to follow this horseshoe crab, which is actually really funny, right up into the point that it gets stuck in something, or something happens and it dies and it fossilized behind its trackway. This is a very, very beautiful example. So we can see this huge horseshoe crab traveling. But horseshoe crabs have been around for like, I think it's like 420 million years or something crazy like that. But coming back over here, we get to look at the pathologies, which is a very important study. This shows us that injuries and things like that, this looks like a beautiful example. If you can get close to this, you'll see that this right here is broken. So this allosaur would have had this bone broken, meaning that you can see that something happened within its life. This is probably the reason it died, because it had its broken leg, so it probably couldn't really move much. These appear to be real fossils too, which is amazing. But pathologies tell us kind of some of the interactions that these creatures would have had. This massive allosaurus probably could have been anything from a Apatosaurus bull whipping its leg and shattering its bone. I mean, it tells us that these things fought, how they moved, how they lived, the damage they would have taken, if they survived injury. If hadrosaurs are a good example of this to prove that Tyrannosaurus was predatory. If you see bite marks on something and it's healed over, and you can line up what those bite marks are, you can determine that certain dinosaurs are predatory and more aggressive. Allosaurus is a beautiful example of that. You see a lot of Allosaurus pathologies across the Jurassic. So here we see a lot of those beautiful pathologies. This is a pathological tibia CT scan. Or those are the CT scans. That's the actual tibia, and the CT scan is there. So you can actually see where it was broken. This is Allosaurus. They just put SP. I don't actually exactly know why, because I'm going to guess that it's fragilis, but it could be something else. It could be a hodgepodge of different allosaurids, which is probably the most likely thing. Geodized humerus. You see that? So this upper arm bone of an Allosaurus is hollow on the inside, and you get those things like silica and quartz. They'll seep in there if it's broken, and geodes will kind of appear. You got this second Allosaurus, question mark there with that. The tibia belongs to a second Allosaurus discovered at the Cheryl's Bind dig site. And you have this air sac here, which is a cervical neck vertebra, reveals a pneumatic air sacs that helped Allosaurus take in and store extra oxygen. These air-filled spaces are similar to those in modern birds. So this helps these, especially pursuit predators, where they have to sprint after creatures. Allosaurus is a beautiful example of this because it having to suck in a lot of oxygen all the time, even whenever it's exhaling, it's still breathing in air. But yeah, here's this beautiful dig sites of all kinds of Allosaurus bones. You have some Camarasaurus in there. This is all Camarasaurus. You start to see some of that Camarasaurus, but you do see a lot of Allosaurus. If we come over here, we'll hit Archaeopteryx in a second. We still see the Schloenhof quarries, where we start to see some in Germany. You start to see a lot of lizards, weird aquatic lizards that look like they don't have legs. That looks like a beautiful painting. That's a lithographic plate. You see dendrites, which are crystal freeform. That's the crystal freeform there. You see sharks are abundant there. You even see, if you get close here, some of these flying reptiles, these pterosaurs down here. But you also get to see lizards. So this would have been a marine environment, indicating some of these marine lizards. And then we come over to one of the most famous fossil pieces of Germany, which is the Archaeopteryx. These things are, again, the weird deciding factor. It's pretty much up to debate whether you want to call it a bird or a dinosaur. I call it a dinosaur because it actually has a tail, it has teeth, and it doesn't actually have powered flight. So I call it a dinosaur. It could be up to interpretation because of the feathers and things like that, and the hollow bones if it's a bird. This is a Paravian dinosaur, is what it's usually referred to as, where they have that semi-powered, not powered, but like soaring capability. These things would have been in southern Germany and discovered in limestone in southern Germany. Archaeopteryx is one of the most famous fossils ever found. It shows a remarkable mix of features. Feathers like a bird, teeth like dinosaurs, but these are just, they even have that sickle claw that is abundant of Maniraptor forms. That is because they are descendant down that lineage a little bit. It's a little more complicated than that. Then we come back to the Solnhof in ancient environment. You see some of these ray-finned fish, these giant predatory ray-finned fish. More little ray-finned fish down here. You see some juvenile ray-finned fish, and just so this was clearly an aquatic ecosystem where you get a lot of these big old fish and things like that. They have that fossilized feather, it looks like, on the Dead Sea shore of Jordan, which is very interesting. And then coming over here, we get the amphibians. We get some amphibians. It looks like we have some possible more Allosaurus, I'd want to say. We have some beautiful bivalves and things like that. We have some plants on this side with that paleoecology. These indicator fossils are very important because if you have bivalves, it's probably marine. If you have plants, it's probably swampy then. You get some swampy there. So these are very important trace fossils to tell you what the ecosystem looked like. Then we're going to come around here to the baby long neck. This baby long neck display. We'll hit that big display all in one go real quick. These are bones belonging to a juvenile sauropod, a long-necked dinosaur that was likely only a few months old when it died. It was found alongside an adult Apatosaurus in the Cheryl's Bind dig site. However, because so few bones were found and the skeleton was still developing, scientists cannot determine the exact species in front of you. in these beautiful femurs. Just 12 inches long, a stark contrast to the massive adult femur, which could reach an incredible 6 feet 7 inches in length. This tiny fossil offers a rare glimpse into the early stages of one of the largest animals to ever walk the earth. So you get these baby sauropod femurs. Then we get bite mark or tool marks, which is an interesting indicator there. Carnivorous dinosaurs were less common than their herbivore counterparts, making any evidence of their presence, such as bite marks, especially valuable. These tooth marks on the sauropod bones, made by a theropod, buried to be preserved on there. So this actually shows predation of these massive creatures. So if you look at the tooth marks, if you see those tooth marks, I'll try and see, you can kind of see them on the giant femur right there. I'll add it in. So you can see that shows that that things like Allosaurus especially were predators that would hunt these things. Hence why we get a lot of debate, especially because a lone Allosaurus is probably not hunting an adult Apatosaurus, yet we see bite marks. So that can also lead us to things like how their jaws work, how strong their jaws are, the killing method that they use, things like that. And this is just a beautiful indicator of looking basically into the life of these dinosaurs. So this is actually marine reptiles of the Mesozoic seas. So up there we have the massive pliosaur. These are not plesiosaurs or mosasaurs. They look similar to mosasaurs, but they ruled the oceans during the Jurassic period. So pliosaurs were these massive carnivorous predators. You can see in their jaws, their teeth kind of come out in that cage-like structure so that they clamp around fish, slippery prey, and they're more like spears than a knife, so just pierce, and so slippery prey can't necessarily get loose. Here we have a plesiosaur of some kind, or an elasmosaurus of some kind. This is Xerophasaurus oceanus. These things would have also lived in kind of those swampy, murkier, darker waters. They're big bodies, they're very heavyweight, they have these giant fin flippers. They're not deep ocean dwellers like they're usually depicted, maybe off coast a little bit, but definitely not deep ocean. They were not built for that. They were built for kind of laying their head down and opening their jaws and then kind of letting prey come in and they'd snap shut. We have these beautiful massive turtles, and get up close to this skull real quick. So as you'll see, what's a good indicator? Here, this beautiful ichthyosaur here, it's a good indicator. You'll see that they have the eye hole, but then there's this other hole. That is because they are diapsids. But turtles, you'll see they only have the nasal and the eye, which makes them look like synapsids, but they're not because they come from the lineage of diapsids. So they're actually diapsids, and there was an evolutionary pressure for them to lose that hole in their skull. What it is, I have no idea. I haven't looked into that in depth. I'd be very interested to see if there's a paper on that. But yep, coming back, there's this beautiful 3D ichthyosaur. It's a very beautiful ichthyosaur. This is a early mini reptiles returned to the water. This group, like mosasaurs, returned to the water. This is a Paleosaurus. This, you can see it's got that very early still land base where they have that feet. Marine reptiles where they were kind of becoming webbed and things like that. Not saying that this necessarily turned into a mosasaur, but these are mosasaur adjacent. One thing I forgot to talk about and bring up over here were these beautiful pterosaurs. I don't remember their name. They look like, I think it's like Tropheus or something like that. Those Jurassic pterosaurs that appear. These are just beautiful, massive. You'll see that they're very fish-based because they have those teeth that are very circular and kind of bend out so they can clamp onto things and pick them out of the water. And coming back to our marine reptiles. We have that beautiful plesiosaur, elasmosaurus, that beautiful pliosaurus. Here, during the late Cretaceous, you have Tethyosaurus, is the only species in its genus, named after the Tethys Ocean, and paleontologist Baron Franz Nopakosa, sorry if I butchered your name. The original specimen was found in Morocco and included nearly a complete skull, vertebra, and limb fragments. Tethyosaurus is classified within Aegialosauridae, an early group of semi-aquatic marine lizards. So you can see that they still have some of those kind of more limb structures before they elongate into paddles, but they're starting to elongate. You see that they're becoming a lot like mosasaurs and monitor lizards. Here, of course, we have that beautiful ichthyosaur. I don't know why I was blanking on it when it's right in front of my face. Ichthyosaur noted the large eyes for hunting in low-light Jurassic Sea. This skull is most complete and largest found. This is that I would love to see if they have Ichthyotitan skull. This one, you can note that its face was broken in some way. Why that happened, I have no idea. It could have ran into a wall, or something could have swam in front of it and it crashed into it and broke its little snoot there. Here we have this beautiful Sundance Sea. I love that we're mentioning the Sundance Sea here. Between 165 and 157 million years ago, during the Middle Jurassic period, a vast shallow sea covered this region, leaving behind the Sundance Formation, a treasure trove of prehistoric marine life. This ancient ocean was home to a diverse array of creatures, including Ichthyosaurus, a sleek dolphin-like marine reptile with powerful flippers, an elongated skull built for speed. You have this, I'm assuming this is an Ichthyosaurus hand then, down here. Coming over here, we get the Dryosaurus, because apparently we love naming things the same thing now. You'll see these remarkable, of course, those aquatic-like teeth. For those, it looks very long and slender, a lot like monitor lizards that would be aquatic. A powerful marine reptile, unlike today's crocodiles, and it's relatively better adapted for marine life. So this thing would be like if a saltwater crocodile just stayed in the ocean a lot of the time. And for our last thing for this section is the Tilialua, I think that's how it's pronounced. This was a marine reptile from the Polycoid family, a group of plesiosaurs. Discovered in Morocco, this species is unusual for its exceptionally long neck compared to others in its genus. This is a streamlined body and strong limbs. It was well adapted for fast swimming in warm Cretaceous seas, likely feeding on fish and squids. So this one would have been one of those plesiosaurs that went more marine and less that shallow, murky environment that you would see, those deep swamps kind of things. So this thing would have hunted squids and fast-moving fish and became out there. And this is a beautiful display of these marine reptiles. This, I'm probably some kind of mosasaur. It looks like some kind of mosasaur. You have those back jaw teeth. You have this elongated digits to build fins to help flap. You have that weird, long, snake-like tail. This is a beautiful mosasaurid, kind of similar family, if it's not a mosasaurid. I don't really see a plaque for it. But yeah, that's a beautiful aquatic creature. But this pliosaur is by far one of my favorite things. It's a beautiful, massive pliosaur. So here in this display, before we touch on this, they have a lot of diplodocus and other sauropod specimen. We have shed teeth. Like other dinosaurs, Allosaurus shed its teeth regularly, particularly while feeding. While Allosaurus skeletons have only been found in 2 quarries, their teeth have been found in every quarry on this ranch. This is a collection of shed teeth from many of those quarries. So you have those shed teeth down there. You have the Camarasaurus teeth, Diplodocus, kind of big toe claw there. You have an Allosaurus claw there. We have a Diplodocus, Apatosaurid vertebra, some brain cases of those massive sauropods, those Diplodocoids. You have gastroliths, which are stones in their stomach, like modern chickens. They'll swallow stones to help grind up plants in their stomach. These are also Diplodocus and SP. That's a caudal vertebra. That is a chevron, which is like the bottom of the end of the tail. So that would have been one of the far chevrons. And this is a beautiful articulated foot. But then we turn around. I have no idea how this is going to get in the shot. We have this beautiful Camarasaurus. This is Morris the Camarasaurus. Comes from our site from our site's bedside sauropod, the west of the bedside sauropod, on the Warm Spring Ranch. Camarasaurus was one of the most common sauropods in the late Jurassic period, often seen roaming in herds across ancient floodplains, growing up to 60 feet long. It had a short but powerful neck and strong spoon-shaped teeth, perfect for stripping tough leaves and trees and branches. Unlike many sauropods, Camarasaurus had sturdy, weight-bearing hind legs, just like these, that allowed it to rear up on its back legs. Using its long tail for balance, this unique ability gave it access to vegetation that would have been higher up or not accessible to other things. So this specific Camarasaurus is 95% complete. With more being found every year, the black bones on the skeleton are Morris real bones, while the tan are replica bones. We have yet to find. When we do find these bones, they will replace the tan ones with the real bones. Tens of thousands of man hours have been put into this. So if you see here, this is a good example. Right here on the foot, you have like the black bone here of Morris. Then you have the tan bones here, which are the fake or the replicas, the recreations of other, comparing other Camarasaurs. They have 95% of this Camarasaurus. Now if we come over here, we get this articulated Camarasaurus arm. As this is beautiful, you have that huge foot there. So yeah, you have the radius, the ulna in the front, and that front foot, that big old front foot there. This beautiful, massive, articulated Camarasaurus. Yeah. Then we'll come over here before we hit that big old, I want to call that Supersaurus. It's probably Supersaurus. We get, dear Lord with these names, Mymora pelta, meaning shield of Mygat Moor, was named in 1994 after his discovery in the Mygat Moor quarry in western Colorado. It was the first Jurassic-aged ankylosaurus found in North America and is one of the only two known from the Morrison Formation. Covered in these giant bony osteoderms and plates, you can see it doesn't have that club tail like the famous ankylosaurus. That would have been to protect from predators like Torvosaurus, Ceratosaurus, and even Allosaurus. So you start to see this lineage, these lineages of Eopod, of the Ankylosaurs and Stegosaurs split off from as early as the Jurassic. So then we have Nanosaurus here, which are these agile little ornithopods here. They are herbivorous. These would have been the light snacks of the Jurassic. Over the years, this dinosaur has gone by several names, including Othnielia rex, Ornioleosaurus, and today it is recognized as Nanosaurus agilis. So you have these little tiny groups that would have possibly intermingled and lived in packs for safety. Turning over here, we have this Allosaurus skull right here. Holy sheesh. We have more Allosaurus teeth up there. I'm still trying to get over this beautiful Allosaurus skull. Frontals, the Allosaurus frontal bone, are paired with and held together their bony suture, C frontal on the right. We have this brain case of Diplodocus and Apatosaurus, I think, is on each side. Then we have this Camarasaurus skull, this beautiful, massive, partial Camarasaurus skull. This one would be real, I'm assuming. That makes me curious because the Camarasaurus skull up there is tan, meaning that that's not the real one. I'm curious if this is from Morris and they just couldn't mount it good enough for it to not fall apart. I really don't know. Then we have pathologies and taphonomy. We have broken ribs of, we have Jimbo the Supersaurus. The ribs below belong to Jimbo, our Supersaurus. After Jimbo died, but before his bones were buried, some of them began to rot. The interior spongy structure of this rib was wearing away. So you start to see it rip. Your ribs are supported by like muscle and things like that. While they also do support the muscle, they work together to kind of help support each other. Take away one of those and let it rot and fall apart, the ribs start to kind of collapse in on each other. So you start to see that. You have that broken geodization of probably a sauropod of some kind. Or you have examples of arthritis. Arthritis is a common problem in humans and dinosaurs. Osteichthyes, these are some beautiful. You have some deformed ribs here. We have these traumatic injuries here. So you'll see that's ossifying and healed together. So you'll get the vertebra from the tail that fuse together to kind of help support it and heal. So you'll tell that there was a break or something there and the vertebra's fused. These are from the tail of an Apatosaurus. This is genetic defect. So this is actually something that I find interesting because we usually depict dinosaurs as like standard birth. I know it's like a weird thing, but like dwarfism and giganticism would be a thing that would exist for them. So the Loris Apatosaurus core has produced a partial associate but disarticulated Apatosaurus skeleton. Of partial interest is a set of fused vertebrae below, which represent the first reported case of a congenital present from birth malformation in a sauropod dinosaur. If we come over here, we get some Stegosaurus skin impressions. On here, you can see some of that skin impression, especially if you get close here. Actually, if you look right about there, you'll see that skin impression of the top area. Those are skin impressions of that. Then we get the famous Thagomizer from a Far Side cartoon by Gary Larson is where it actually gets its name. So it's not scientifically called a Thagomizer, but if you refer to it as Thagomizer, everybody knows what you're referring to. That appears to be some kind of jaw because those look like teeth at the top there of some kind. You have that held bite mark. Below is the caudal vertebra from the midsection of the tail near the top of the neural arc. You can see a large hole. If you come here at that, let's see if I can point out that large hole right there. This is the result of a bite from a predator that started to heal, indicating that the Stegosaurus survived it. Then you have this lower jaw. Skull material is often very difficult to find due to its fragile nature. This lower jaw is only portion of a skull recovered from our Stegosaurus. Can you see the row of holes where the teeth were? If you look at the, I want to say it's the bottom there. I think it's upside down maybe because it doesn't make sense to put it at the top. I don't really exactly know. But here we come to the Stegosaurus. This is a beautiful Stegosaurus recreation. You show it in action with this juvenile Allosaurus, or this is a juvenile Allosaurus fragilis. Allosaurus may have hunted in groups, allowing them to take down more dangerous prey like Camarasaurus or Stegosaurus. This baby Allosaurus would have traveled with other Allosaurus for protection or to hunt more successfully. So Allosaurus is a very interesting one because as I've mentioned, I do want to write this paper. I need to figure out when and how and all that good jazz. So Allosaurus may have more than likely hunted in packs because of the prey of its time with these giant stegosaurs or those dangerous stagomizers, those giant plates and just these massive bodies. It doesn't make sense to go at it alone. So you have one target one side, one target the other side, maybe some go for the legs, and they just, for lack of better words, draw and quarter it, just ripping it apart. But for some of these smaller creatures, like is it Nanosaurus? Yes, Nanosaurus here. What sense does it make for a full-grown Allosaurus to hunt one of those? For a multiple to hunt one of those? So it might depend on their prey preference. So Supersaurus back here, Camarasaurus, Stegosaurus, Allosaurus would have most likely hunted in packs. But for smaller creatures like the Dryosaurids and the Ornilestes possibly, even Ceratosaurs to an extent, Nanosaurus, it would more likely have hunted alone. But this is a beautiful juvenile Allosaurus specimen here. And then we're going to move on to their Supersaurus, but first we have their Diplodocus growth series. Beautiful, massive Supersaurus. I know Dr. Brian Curtis would love this. His favorite dinosaur is the Supersaurus. So you can see the bone beds of how they would have grown. Warm Spring, this is from Warm Spring Ranch, has yielded a disarticulated remains of at least 6 to 7 sauropods. These bones were likely transported by water before burial, scattering the skeleton into jumbled bone piles. Because of this, much of what we learn comes from the fossils are carefully removed and prepared in the lab. Shown here are 3 Diplodosaurus tibia, the lower leg bone, one of the lower leg bones, each from a different life stage. A very young individual, like a toddler, a juvenile or a teenager, and a full-grown adult. This may have suggested they traveled in family groups, though it also is a possibility that these bones were mixed in from different locations during transport. So this is a beautiful indication of how they would have grown through just one bone. Then we have this articulated leg here. At the west beside sauropod site, paleontologists uncovered these Camarasaurus bones in a rare, fully articulated state. Positioned just as they were in real life, among the discoveries is a complete hand down here with claws intact alongside with the radius and ulna still in place. Finding fossils in this condition is uncommon and provides valuable insight into how these dinosaurs lived and died. Such exceptional preservation suggests this dinosaur was buried quickly after death, keeping the bones from scattering, while WBS has yielded several well-preserved Camarasaurus, the west beside sauropod, yielded several well-preserved Camarasaurus sections. A fully intact skeleton has yet to be found, but this is a beautiful just size of this massive Camarasaurus foot. This is probably a younger one just because of how tiny it is. So the chambered lizard here, don't know why this isn't over there with the other Camarasaurus, but whatever, we've already talked about. But then we get into the Supersaurus, this massive beast living up to its name, the Supersaurus. Below is the caudal or neck vertebra. This is one neck vertebra over here. I mean, just looking at the size of this thing, it's the size of my leg. And that's like one neck vertebra. And then here's this half a small cervical, which would have been farther up. Then we get the pneumatic bones. Some dinosaurs like Supersaurus had air-filled spaces in their bones, a feature called skeletal pneumaticity. That, of course, helps it be lighter weight because just such a massive creature, if it weighs too much, it can't move. Gravity screws it over. It collapses to the ground. Doesn't make sense. So it has to kind of figure out little shortcuts. So instead of having just an entire solid bone neck, it has like air sacs and in its ribs and things like that. There would have been air sacs to kind of help alleviate some of the weight of this thing. Here we have this beautiful vertebra here, and here's this scientific paper. If you want to get close to that, so if people want to scan that, I'll take a picture of it so I can put it in there. If anybody wants to figure out how to take a screenshot and scan that so you can go to that scientific paper to see the age of Jimbo, I'll leave that to y'all. Coming over here, we have a tibia of the Supersaurus. These giant, massive tibias here. So that would be, that's the front limb, which is a little more difficult. It's kind of that bone right there would have been the tibia. That's the real tibia of Supersaurus, of Jimbo the Supersaurus. So Jimbo the Supersaurus provides a striking example of an elderly dinosaur. Researchers performed a histological analysis studying thin slices of bone tissue under the microscope to estimate his age. And by counting remodeled bone cells, they discovered its age. So, I mean, you can only imagine that these things, they're like reptiles in the sense that they just keep growing eternally. So you get just these massive creatures that would have just roamed the earth in these giant herds too. And one of the things about Allosaurus, since we were mentioning that earlier, is how they would have hunted these things. Since they have to hunt in packs to take down something like this, there's no way a lone Allosaurus is taking down one of these. You get those Camarasaurus and Supersaurus here. One of the theories that they do is, and through pathologies, they would target the things like ankles or wrists or vital areas where you would get major arteries that come down. Because think about like your Achilles tendon or like the veins in your wrist. Think about how many you have and think about how many these things would have. You target those, you tear them open, these things just kind of wander around and slowly bleed out. So you get Allosaurus, they'll do that, and then once it falls over, too tired to fight back or from blood loss, they just go in and have this giant feast. But this is a massive Supersaurus. I don't even know how you would get this thing in one shot, but it's just huge. But then we come over here. Let's hit Supersaurus first. Jimbo Quarry is a treasure trove of scientific discoveries, offering detailed look into Wyoming's Jurassic world. This site produces both the largest and smallest, with Hesperonithidoids. Very difficult. I don't speak Latin. Dinosaurs ever found in the state preserved side by side. So here we have this massive fibia, this massive vertebra, you have that vertebra, and these humongous creatures that lived and roamed the earth. And here we get from the size of Supersaurus to these fellas, like Archaeopteryx, I guess, comparing Lori to these small theropods. So I guess this is Lori, if I'm not mistaken. Maybe this is Lori, I don't really know. I guess these are Lori, yeah. So just seeing how tiny these things are, these Hesperonithidoids. So you get this guy, which is I want to say a velociraptor that looks like of some kind. Maybe this is, I think this is actually a recreation of Lori, so I was right. But you get this Deinonychus, or Deinonychus, as some people like to say, and you get these other velociraptor. You have that velociraptor skull, Archaeopteryx skull, it looks right there, and maybe one other. I think one might be a Compy, one might be an Archaeopteryx. But I mean, what is the big deal with this? The newest, smallest species of dinosaur from the late Jurassic period. Lori is 150 million years old, from the rock layers known in the Morrison Formation. Well-known dinosaurs like Allosaurus and Stegosaurus are found in the same rock. Any new dinosaur from this famous formation is a big discovery. The earliest member of her family in North America and maybe the world. Lori is a small meat-eating dinosaur, is a Troodontid, which is part of the Maniraptoran family. Velociraptor is the most famous member of this group, which indicates that the formation it was in, that Archaeopteryx, which also includes Archaeopteryx. Lori is a new link in the chain of bird-like dinosaurs, where you get that early kind of bird stage that turns into birds, and actual dinosaurs themselves. Lori was found outside of Douglas in south central Wyoming in a small site as the WDC Wyoming Dinosaur Center Supersaurus. Same site as the Supersaurus here. They were only 4 inches apart from each other. Finding a dinosaur this small next to another that large was thought to be impossible until now. And actually, it makes sense. Maybe a lot of the groundwater was seeping into this, so it was able to preserve some of this. I have no idea. But this just goes to show how big of a range the Jurassic had. From dinosaurs this tiny, where it would have been like yay big, to Supersaurus over here. Like, I mean, it's just getting absolutely massive. So here we come to the king of the dinosaurs during the Cretaceous period, the Tyrannosaurus Rex. This is a recreation of Stan the T-Rex, which was moved to England, then I want to say was recently sold to a museum in Saudi Arabia. I don't remember. I wouldn't be surprised. I know a T-Rex was sold there. I don't remember if it was Stan or another one. But this is Stan the T-Rex, who discovered his first bones excavating in South Dakota in 1992. You get these huge bone-crushing lower jaws, these huge robust teeth for just crushing. This has a presentation that says hunter versus scavenger, and I know that's a Jack Horner paper where he said that T-Rex was a scavenger. I just want to point this out. What about these teeth says scavenger? Also, we have bite marks from ceratopsians like Triceratops, Torosaurus, Hadrosaurs that have healed for surviving Tyrannosaurus attacks, which is just the smoking gun evidence right there that T-Rex was not a scavenger. And these things would have had part of their brain that deals with senses like sight and smell was massive. So they had amazing binocular vision facing right at you, and they could smell. They had some of the best smelling capability in the animal kingdom. And then we come over here to one of the weirder dinosaur groups. This is Northochirus, discovered in 2001 in New Mexico's Zuni Basin. This dinosaur was the first therizinosaur found outside of Asia, meaning that they did come over here. These things are so weird. They fall in the theropod lineage. They had those giant, see if I can, oscular rings that would have possibly helped with better vision or night vision. You'll see that if you face it straight on, it can kind of see forward. It's very difficult, but also you'll notice, so you have some forward capability, but the eyes are still pointed that way, indicating that this tiny thing was probably prey. This unusual dinosaur stood about 6 meters or 20 feet long with a pot-bellied body, long neck here, so you have that big chunky body with that long neck, and broad hands that tipped about 30 centimeters or a 12-inch claws. You come and see these massive claws right here. These things would have been gnarly to deal with if it slashed you right across the face there. That would just tear you wide open. It is thought to belong to the meat-eating theropod group. Its leaf-shaped teeth and bulky gut show it was deducted to be a plant eater, which is very weird. So you get carnivores that eventually come from that lineage of theropod that turn back into plant eaters. probably because they needed to get big, and those massive claws were just remnants of theropods. But you still see those theropod-like feet. You still see a lot of those theropod structures. You still have that theropod Saurischian hip, or ornithischian if you want to be semantical about which argument you want to have. That beautiful stand in the background too. So these things were really weird. So this is our Therizinosaur for America, which was thought to not be a thing until now, but we do have those. Snail paste work. This is also part of the model portrayed how a Therizinosaur embryo might have appeared before it died and its bones became disjointed. So you have some of those weird embryos, those dinosaur embryos that would have been from eggs and things like that. Then we come over to a more peaceful, motherly dinosaur, the Maiasaurus, meaning good mother. So this was one of the dinosaurs that was found directly correlated with a nest of young, indicating that it did care for its young, which I'm sure could be carried over to other hadrosaurs or ornithopods, things like that. But we do know for sure Maiasaurus. So you have that big old duck bill, you have those dental batteries, you have that tiny little nest here, indicating that good mother behavior. We have that giant body. Maiasaurus is not even one of the biggest hadrosaurs, but it still comes in at a very impressive height. Then we come here, we have a lot of Maiasaur actually. We have the skull of one, we have an articulated arm here, we have this tiny, unique example of a juvenile Maiasaurus of a nesting age. Well, not a baby. This Maiasaurus could not have yet survived on its own, probably having never left the nest. It would have relied on its mother for protection. Then we get this other, are these two different species of Maiasaurus? I think so. I think that's why they are side by side. You have this big Maiasaur here. This is a beautiful example of a Maiasaurus track. You have those very widespread big three toes. It's very rounded, indicating those rounded feet. But yeah, just looking at this thing, you have the ornithischian hip. You have that weird arch there, and it goes back really far. Lived in giant herds, protected their young, things like that. I think this is another Maiasaurus here, with another Maiasaurus track right here, that other massive Maiasaurus. Then we come to Gastonia. Gastonia was a heavy armored dinosaur from the early Cretaceous of Utah. Measuring about 15 feet long, it belonged to a group of early ankylosaurs known as Polycanthes, which has like Polacanthus. Known for their distinct armor and hip shield. They have one giant hip shield instead of a bunch of more secularized osteoderms that would build up. They had one just giant hip shield that would hold over their butt, if you want to call it that. Gastonia had a bony plate called osteoderms, large shoulder spikes here, and a broad sacral shield. Triangular armor along its tail may have acted like a swinging club to defend against predators. It lived alongside other famous dinosaurs like Utah raptor. Although the bones were found in a mixed bone bed with several individuals, Gastonia is still the most complete Polycanthini ankylosaur ever discovered. So you see that whip-like tail. It's thought that maybe instead of it getting that giant club like Ankylosaurus, it might have been more, I don't want to say sharper, but think like the Aztec war club where it's got the giant bits of obsidian kind of on the side, so you just kind of slash it. Kind of that principle. There's giant shoulder spikes so you can shoulder stab something if need be. Here we get something very beautiful. We get eggs. We get a hadrosaur egg. Bibelong, I think is how it's pronounced, those. And theropod eggs, so you can kind of see the differences where you get those rounded bulbous ones versus the longer ones. These look all shattered. But then we get into ceratopsians here. But before we go further, let's look at one of the most apparently beloved what am I saying? Ceratopsians. Psittacosaurus had a bunch of different species. This little guy ran rampant across like 3 continents. This one is specifically Mongoliensis. You have this little dead bone bed here it looks like a mother with a bunch of young or something, possibly. But then we go later, you get a little more evolution down the line. This is not what I thought it was. I thought this was a Protoceratops, but this is Zuniceratops. Zuniceratops was discovered in 1996 by an 8-year-old named Christopher Wolfe maybe, in New Mexico. This specimen is about 3 meters, 10 feet, as large as, it has large fenestra holes in its frills, if you look here. That has 2 horns over its eyes. This small ceratopsian represents representing an interesting find. At approximately 90 million years old, this fossil lived 10 million years before any of the large ceratopsians and is now the earliest known ceratopsian in North America. A blend of primitive and derived characteristics, Zuniceratops is considered the transition between early small ceratopsians like Protoceratops and large horned ceratopsians like Triceratops. So you get Psittacosaurus, which over in Mongolia turns into Protoceratops, and somehow that connects into North America, and you get Zuniceratops here. But then we come over to Cosmoceratops and Enoceratops here, with some very beautiful depictions here. We get to see some of those unique ceratopsians that aren't just the Triceratops lineage. This is a member of the ceratopsian family that has one of the most elaborate skulls of any dinosaurs, with 10 unique episifications, I think is how it's pronounced. 8 curved downward, you have those top ones curved down. And the top of the frill, while the others jut outwards from the side, giving it a distinctive crown-like appearance. Scientists believe that these horns may have been used for display, specific species recognition, or defense. This species is the first Cosmoceratops found in Wyoming, expanding its known range from Utah, where previous fossils were discovered near the ancient Western Interior Seaway. If I'm not mistaken, the 2 ceratopsian lineages are broken up. So you have the 2 different lineages, the Chasmosaurian and the Centrosaurian. I don't know why I was blanking on that. I was trying to remember which one was which. Chasmosaurians, like Triceratops and Cosmoceratops over here, were actually a lot more solitary. You get few specific species where they're found in bone bed, but the Centrosaurians are the ones that are in the huge, massive herds, like Enosaurus here, where it has that weird curved out horn. You have those holes in the top of its head, the top holes. Enoceratops is a ceratopsian dinosaur that lived during the late Cretaceous in what is now Montana. Its name means the bison lizard, and uses the Blackfeet language combined with ancient Greek. It is unique among ceratopsians due to its forward curving nasal horn. Like other mini horned dinosaurs, it would have used its horn and frill for mating display, and presence of large fossils of Enosaurus closely resemble its relative Styracosaurus, which would have the one horn here, and was originally named as a new subspecies of it before officially being described in 1995 as Enosaurus. So you have that. Then we come over here to the beautiful Protoceratops. This fella here is one of those early staged ceratopsians. This one is from the famous Mongolia, but also one of the interesting things is the Gobi Desert of Mongolia is famously found with the dueling dinosaurs of Velociraptor and Pachyrhinosaurus here, which means that they lived together and would have interacted and clearly interacted. So Protoceratops is one of those early ceratopsians that you see. So that is a very beautiful example there. This is Medusasaurus loki, because we love naming it. It's named after Medusa, the mythical creature with snake for hair. Medusaceratops had downward pointed spikes on the back of its frill. If I can, so you're looking there, you get those backwards pointed, downwards pointed spikes. Likely used for ornamentation or display. Unlike later ceratopsians, it had a more primitive build, like a shorter, less robust frill. So if you see it's kind of lower down. Things like that is a good indicator. This is part of the Centrosaurian line. So you notice that nose horn isn't quite there. You get those, that nose horn isn't quite there, and you get those kind of jutting out. Those probably would have been longer due to the keratin sheaths. But these, since they're Centrosaurians, would have most likely lived in giant herds. And then we come over to Triceratops over here. We get the famous Triceratops. This one has horns or holes in its frill, which I find interesting. But you get those famous three long giant horns. This one is Horridus. I think we've been seeing Perorsis, and it's kind of hard to tell since this is a recreation. It should be sloped a little more, that keratin sheath there. This is one of the later ones. These fall into not Centrosaurians. Yes, Centrosaurians, if I'm not, I think Chasmosaurians actually. I think Triceratops falls into Chasmosaurians. Yes, that's what it is, not Centrosaurians. So you get that beautiful dental battery back there with the beak for pinching and piercing leaves, the dental battery for, of course, grinding it away. These are surprisingly solitary, with the largest group of Triceratops ever discovered being 5. So all the depictions of them being clumped together is not real. Then we come back over to Medusa, where they have talking about some of those primitive builds. They have that robust frill. They have the less heavy built skull. Medusaceratops was originally misidentified as Styracosaurus and Albertoceratops before being re-identified in 2010. The Wyoming Dinosaur Center collection houses the holotype and some par-type specimens of this dinosaur, but it's very difficult to tell what ceratopsian you have if you just have like the tip or just this part. It gets very difficult. Then we come over to our theropod display. We're going to come back all the way over here. We have that beautiful ceratopsian display with this fella, Falcarius, discovered in 2001 in Utah's Crystal Geyser Quarry. This is considered a key transitional species between meat-eating theropods and plant-eating Therizinosaurs. So you also get this. It is a relative of the Therizinosaurs, one of those early ones in possibly North America. You get that long neck, a little less robust of a body. It's slowly becoming robust. They're slowly getting bigger. You can see the claws are kind of growing out a little bit, getting a little gnarly. But you can tell it's plant eating. Primarily, if you get close here to these teeth, they're a little sharp still because it comes from that theropod lineage. But you can tell that they're becoming rounded like plant eaters. Then we come over here to Conchororaptor from the late Cretaceous. Is a small beaked theropod. You can see this little beak here. Thought to be an omnivorous, possibly feeding on eggs, shellfish, plants, and small animals. Its strong, toothless jaws were likely adapted for crushing hard food items. Once later determined to be a distinct species from related, once thought to be juvenile oviraptor because of its lack of head crest, it was later discovered to be its own species and a relative of that. Conchocoraptor would have been feathered, giving it a bird-like appearance, and it comes, I'm sure, from that oviraptor species. You have that oviraptor-like head. Oviraptor would have a crest that comes up here, but you can see that beak there. You see those claws staying on those back two legs. Then we come over here to the famous velociraptors, of course. Velociraptors belonging to the dromaeosaurid dinosaurs, dinosaur group, whose shared characteristics include a long tail. You have that long tail, that bipedal stance, meaning it's on two legs, and a elegant sickle-shaped claw, kill claw, on its toe, the famous sickle-shaped kill claw. They are also known for being bird-like with feathers and hollow bones and an S-shaped neck that curves up and a crescent moon-shaped wrist bone. That, trying to get close there, it's kind of hard to show. I don't even know how I'd get a good angle. But if you look at that wrist bone there, it's kind of that crescent moon shaped. Then we come over to the beautiful Bambiraptor. These weirdly elongated digits, that long tail, related also in the dromaeosaurid. Bambiraptor is a species of theropod that was found in northern Montana by a 14-year-old Wes Linnister, and the original species was a 95% complete skeleton measuring about 3 feet long. Like modern birds, Bambiraptor had a wishbone, was most likely covered in feathers, and had a brain comparable to the size of modern birds. In fact, it made the largest bird of its size of any dinosaur. It had the largest brain, for its size of any dinosaur, which researchers believe may have evolved as a result of hunting agile prey, such as lizards and small mammals. And you get these really weird elongated fingers for like reaching out. You get some of those really weird creatures there. Then we come over here to Sasuke tyrannus. Was discovered in 1998 by a 16-year-old Sterling Nesbitt in the Zuni Basin of New Mexico. The two known specimens, likely juveniles, stood about 3.3 feet tall or 9.8 feet long and weighed about 20 to 40 kilograms or 44 to 88 pounds. Initially thought to be a small raptor. It was later identified as an early small relative of Tyrannosaurus rex, it name meaning the Coyote King, combining the Zuni word Suzuki, coyote, and the Latin Tyrannus, king. Hazily honors Hazel Wolf, which is, I guess, who supported fossil research in the Zuni Basin. And here we come to one of my actual personal favorite and underrated Tyrannosaurs, Alioramus. I like to say Ramus because it sounds cooler. They have this really weird elongated face and snout. These are part of the Asian branch of Tyrannosaurid family. In fact, its name means different branch because it diverged from other tyrannosaurs. Discovered in 1970, the only remains of Alioramus have come from Mongolia in the Gobi Desert. Unlike his more famous cousin, Tyrannosaurus rex, like stand there, the skeleton of Alioramus is much smaller, reaching only 6 meters or 20-ish feet. Other differences include smaller, more elongated skull here. You get that interesting crest there too. That contains the highest number of teeth found in any tyrannosaur, and a set of 5 bone ridges along its nose. If you look right about here, you can see those 5 bones. 1, 2, 3, 4, 5 there, that little ridge there. More likely used for display. And if we come around here, you can see Gorgosaurus, one of the earlier North American tyrannosaurs. It's not a T-Rex. At the first look, the Tyrannosaurid skull you see looks almost exactly like the skull of a juvenile T-Rex, but that is because two medicine formation is roughly 15 million years older than the rocks that the T-Rex is found. At least two other specimens of Gorgosaurus have been recovered from the quarry. A much smaller animal. Look at the little jaw here. If you look down there, that is the jaw they're talking about. And a much larger individual is on display in the Children's Museum of Indianapolis. But this is that beautiful Gorgosaurus there. It was in Alberta and northern North America, along with Albertosaurus, of course, and Nukasaurus in Alaska. Gorgosaurus might have come up into Alaska. So that actually leads me to think that these are somehow a direct lineage into Tyrannosaurus rex, coming farther south and getting a necessity to become larger. So you get these so it's weird that you get these Asian species like Aleoramus and things like that, and Tarbosaurus. That Tarbosaurus evolved around the same size, same time as Tyrannosaurs. They're considered sister taxon somehow. But you get them, they come into North America, you get Nukasaurus, Gorgosaurus, Albertosaurus, and then later Tyrannosaurus. They come down and they evolved into Tyrannosaurids. Now if we come over here, we get first we get the Archelon, which is this massive prehistoric turtle, just absolutely huge. But if we come in here, we get a lot of the post-dinosaur creatures. We have predators of the food chain, with Archaeotherium here, down here, and Pobrontotherius up here. We get those huge predators. We have food catching here, where it's this food catching event here going on. We get some of these saber-toothed creatures here, are beautiful examples. We have this bear dog mammal right here, very weird looking creature, and this Marichaeodont, or Don. We get these beautiful saber-toothed relatives here of the White River Formation. We get a lot of these mammals here. We get a lot of mammals, rhinoceros, early remnant Arthrodactyl. We get the other insectivore mammals. We get Orionodonts, which are like those weird, not pigs, horses that might have burrowed or stolen turtle burrows, depending on who you ask. We get, of course, we get turtles and tortoises. We get tortoises. We get rodents, are very prevalent. Try and get some of these rodents in here. We get rabbits and rodents in there. You get those rats and things like that, or squirrels. We get extinct rats. We get fish still, because fish are still around today. We get turtles and tortoises. We get crocodiles, bowfin fish, bipedal small mammals are a thing. We get birds up here, and primate-like mammals, where we start to see those primates with remarkable preservation. If we come over here, we get more other mammals. Some fossilized bats are important because we see that convergent evolution with wings. We see small birds, frigate birds, hummingbird relatives. That's very important because hummingbirds fill in the niche of bird pollinization. Then we have those weird relatives. I think that is all for this museum. They have a lot of amazing specimens, from their stand, the T-Rex, to their amazing Allosaurus, Camarasaurus, and Supersaurus, with Stegosaurus here too. They have a lot of Jurassic Formation creatures because that's what's around. I think this is a very beautiful museum, and if you get the chance to come out and check it out, they do dig programs too. I know that's the thing. Oh, yeah, one other thing before we sign off here. If we come around here, oh, we have more fish and turtles. We have garfish. It's preserved very well because of their enamel-covered scales. You get not lobefin, rayfin fish. You get modern 50 million year old Green River Formation, Wyoming, in Kimmer and things like that with stingrays. I don't know why I was blanking on that. You get turtles and things like that. You get garfish, massive garfish, and palm fronds. And if we sneak through here real quick, excuse me, sorry, we get a beautiful open prep lab so you can watch what they're preparing. They have this beautiful caudal vertebra here. So whenever they bring things out of the field, they bring them here, they take them out of the jacket, they prepare them if they're going to go on display or if they're going to go into storage, things like that. Here is a good example of kind of what the preparation process might look like, what comes out of the field as they crack open the gate there, they're not the gate, the plaster there. You'll see the bone. They'll take a lot of the dirt, as much of the dirt out as they can without breaking apart the fossils. But this is a beautiful museum. That is a beautiful Supersaurus, Camarasaurus. They have the Allosaurus over there. They have Stan the T-Rex. I'm really happy that I get to see this Alioramus. So yeah, if you get the chance, come out to the Wyoming Dinosaur Center, check it out, go on a dig with them. They have a lot of amazing specimens.